Beneath the endless dark of the Kuiper belt drifts a world of silence, a shard of ice and stone, orbiting at the farthest frontier of the sun's dominion. Pluto, once dismissed as a frozen relic, a planetary exile, relegated to the margins of astronomy. Its surface lies locked in nitrogen frost, its mountains sculpted from water, harder than granite, its atmosphere fragile and fleeting, evaporating into space like breath in winter air. To gaze upon Pluto is to look into the stillness of eternity. And yet, beneath this silence lingers a whisper. For when NASA's eyes reached it, Pluto revealed not the death of worlds, but the stirring of mystery. Vast plains flowed with glaciers that seemed impossibly young, as if the planet's heart still beat beneath its icy shell. Red organic stains painted the surface, the chemical fingerprints of complexity born under the gaze of distant starlight. In its shadows, science began to wonder, what if emptiness concealed endurance? What if life itself had chosen to hide in the places least imagined? Philosophy once bound life to the warmth of stars, to oceans lit by skies. But Pluto defies such simplicity. Here, far from the nourishing light of the sun, the rules tremble. Could survival feed on chemistry in the black silence beneath the ice? Could alien breath stir in caverns where no human has ever walked? The haunting question rises from the edge of the solar system. What if Pluto, thought to be barren and forgotten, is not lifeless at all, but alive in ways we have never dared to dream? In the winter of 1930, a faint smudge of light emerged on the photographic plates of a young astronomer named Clyde Tombaugh. Working at the Lowell Observatory in Flagstaff, Arizona, Tombaugh was no seasoned veteran of the skies, but rather a farm boy with relentless patience and an unwavering eye for detail. Night after night, he compared images of the heavens, searching for the subtle wanderer that Percival Lowell had once predicted. And then, in February of that year, he saw it, a distant speck, shifting ever so slightly against the tapestry of the stars. It was christened Pluto, after the Roman god of the underworld, a name chosen by an 11-year-old schoolgirl in England, Venetia Burney. The name fit perfectly, dark, cold, and unseen by human eyes until that moment. For a generation, Pluto was heralded as the 9th planet of the solar system, the farthest sentinel orbiting in icy exile. To the public, Pluto became a symbol of mystery, a lonely world adrift at the edge of cosmic awareness. To astronomers, it was a triumph, proof that patience and persistence could extend humanity's reach into the unknown. Yet even from its earliest days, Pluto carried a shadow of doubt. Its orbit was strange, elliptical, and tilted, crossing paths with Neptune as though it followed rules written outside the neat geometry of the classical planets. Its mass was far smaller than expected, unable to account for the perturbations in Uranus's orbit that had inspired the search in the first place. Still, it was enough to capture human imagination. Pluto was real. Pluto was ours. As decades passed, Pluto receded into the background of astronomy's great stage. The outer planets, Jupiter, Saturn, Uranus, and Neptune, revealed their storms, their moons, and their grandeur through telescopes and spacecraft flybys. By comparison, Pluto remained only a dim blur. Even in the best observatories on Earth, its true face was hidden, blurred by distance and darkness. Scientists speculated endlessly. Was it a frozen desert, Did it possess an atmosphere, however thin? Was it merely a frozen relic, a leftover shard from the birth of the solar system? In truth, Pluto became less a world and more a myth, an enigma, too small to dominate, too distant to embrace. But in the quiet recesses of the astronomical community, debate never ceased. As technology advanced, and as more objects were found beyond Neptune, Pluto's uniqueness began to crumble. By the late 20th century, astronomers discovered a vast reservoir of icy bodies, the Kuiper Belt. Here were hundreds, perhaps thousands, of frozen objects orbiting the sun, some even rivaling Pluto in size. One by one, the discoveries piled up, and the pedestal upon which Pluto sat began to erode. Could it truly remain a planet if it was merely one among many? The decisive blow came in 2006. The International Astronomical Union convened in Prague to settle the matter. In a decision that rippled across science classrooms and newspapers worldwide, Pluto was stripped of its title. No longer the ninth planet, it was reclassified as a dwarf planet, relegated to a new category that placed it alongside other distant, icy bodies. The backlash was swift and emotional. For decades, children had memorized Pluto as the final note in the planetary symphony. To erase it felt like erasing part of the human story. But in the halls of science, the decision reflected precision. A planet, by new definition, must clear its orbit of other bodies. Pluto, ensnared in the cluttered debris of the Kuiper Belt, could not. It was no longer the master of its path. And so Pluto became a symbol of exile once more, a fallen planet, a misunderstood wanderer pushed to the margins of the solar system. To some, it was a demotion. To others, it was liberation, a recognition that the solar system was far stranger and richer than once believed. For Pluto's story was not over. It was only beginning. For as telescopes sharpened their gaze and as spacecraft grew more ambitious, whispers of Pluto's hidden complexity began to stir. Spectroscopic studies hinted at volatile ices, nitrogen, methane, carbon monoxide spread across its surface. Changes in brightness suggested seasonal shifts in its tenuous atmosphere, freezing and thawing as it drifted along its elongated orbit. Pluto, it seemed, was not dead, but restless. The turning point came with NASA's New Horizons mission. Launched in 2006, the very year Pluto lost its planetary crown, the spacecraft was tasked with the unthinkable: to travel 3 billion miles across the gulf of space, and to reveal, for the first time, what Pluto truly was. For nearly a decade, it sailed outward, through the orbits of Jupiter and Saturn, past the winds of the heliosphere, into the cold silence of the Kuiper Belt. When New Horizons finally approached Pluto in July of 2015, humanity held its breath. For 85 years, Pluto had been nothing more than a shifting speck of light. Now, at last, its face would be revealed. What the spacecraft discovered would astonish the world. Far from a frozen relic, Pluto displayed a complexity that defied expectation. Mountains of ice, vast plains, glaciers flowing across its surface, and perhaps even the possibility of oceans hidden beneath its frozen crust. The exile had secrets. The forgotten world had life written in its geology. And so Pluto's story, once thought to be one of demotion and dismissal, was reborn as one of mystery and defiance. It was no longer simply the ninth planet, nor merely a dwarf among giants. It was something else, a window into the outer solar system's secrets, and perhaps into life itself. In the cold silence at the edge of the sun's dominion, Pluto had waited, not to be forgotten, but to be discovered anew. And in its unveiling, it transformed from the faintest smudge on a glass plate into the center of a new enigma, a reminder that even the smallest and most distant worlds may hold the greatest mysteries of all. Across the black gulf of interplanetary space, a lone traveler drifted for nearly a decade. Launched in January of 2006, NASA's New Horizons was built for a single purpose: to lift the veil from a world that for 85 years had remained no more than a blurry point of light. Its journey was unprecedented, a 3 billion-mile odyssey through the outer solar system, past Jupiter's swirling storms, into the frozen silence beyond Neptune's orbit. It was a journey into exile, to a frontier humanity had only imagined. By July of 2015, the spacecraft approached its quarry. The target was a shadow on the edge of sunlight, a world so small that even the most powerful telescopes on Earth could not reveal its face. The world was Pluto. The moment of encounter drew near. Humanity had waited generations for this first glimpse, and the images that would emerge would transform not only astronomy, but imagination itself. On the morning of July 14, 2015, the signal arrived from a distance of 4.8 billion kilometers. It took nearly 5 hours for light itself, carrying the data of cameras and sensors, to reach Earth. When the first images appeared, they shattered every expectation. For the first time, Pluto revealed its heart. Stretching across its surface lay a vast, gleaming plain shaped like a colossal, asymmetric heart, later named Sputnik Planitia. Composed of nitrogen ice, its surface was astonishingly smooth, almost entirely devoid of impact craters. To planetary scientists, this was a revelation. Craters are the scars of time, etched into planetary faces over billions of years. The absence of craters meant that Sputnik Planitia was geologically young, no more than 10 million years old. On cosmic scales, it was as though it had formed yesterday. Pluto, long dismissed as a frozen relic, was alive. In the heart of this dwarf planet, scientists saw glaciers in motion, sheets of nitrogen ice flowing like rivers, churning and reshaping the landscape. The plane's surface displayed vast polygonal patterns, evidence of convection cells where ice rose and fell in cycles, driven by heat from Pluto's hidden interior. The discovery was nothing short of astonishing. For decades, it had been assumed that such small, icy bodies were long since dead, their heat lost to space billions of years ago. Yet Pluto's heart was beating still, whispering of forces unseen beneath its crust. Elsewhere, the spacecraft's cameras uncovered jagged mountains rising up to 3,500 meters high, peaks made not of stone, but of water ice hardened into rock by temperatures colder than -200 degrees Celsius. These icy mountains stood as frozen sentinels above the plains, monuments to a geology that was active, surprising, and enigmatic. Even more extraordinary were hints of cryovolcanoes, vast structures like Reitmans and Picardmans, each towering several kilometers high, their surfaces pockmarked and collapsed as if something once surged from below. On Earth, volcanoes spew molten rock. On Pluto, they may have erupted with slurries of water, ammonia, and methane, cold fire from an alien sea. If these cryovolcanoes had been active in Pluto's recent history, then the energy within its depths was far greater than scientists had ever dared to imagine. The shock rippled through the scientific world. Pluto, a dwarf planet exiled to the margins of the solar system, had overturned expectations. It was not a static fossil from the dawn of time, but a dynamic, evolving world. It was as if the smallest voice in the planetary chorus had suddenly sung the loudest note beyond Sputnik Planitia. New horizons revealed further wonders. Pluto's surface was painted in striking contrasts. Dark equatorial regions stained by complex organic molecules called tholins, formed as sunlight and cosmic rays broke apart methane in the atmosphere, recombining it into long chains that fell back to the surface like dust. These red hues marked Pluto as a laboratory of chemistry, a place where the building blocks of life could emerge in frozen form. Its thin atmosphere, once thought impossible to detect from such distance, shimmered with haze layers stretching hundreds of kilometers above the surface. Composed primarily of nitrogen with traces of methane, this atmosphere was tenuous yet active, expanding and collapsing with Pluto's seasons as it orbited the Sun once every 248 years. The haze itself was a mystery, arranged in dozens of distinct layers, glowing blue in scattered sunlight. Here, in the vacuum of the Kuiper Belt, Pluto wore a veil of air, fragile and fleeting, but undeniable. The implications for life were profound. Life, as understood on Earth, requires three fundamental ingredients: energy, chemistry, and time. For decades, Pluto had seemed to lack them all, but new horizons revealed hints of each. Energy, in the form of interior heat-driving convection and possible cryovolcanism. Chemistry, visible in the tholins, and time, abundant in a world that had preserved its secrets for billions of years. Astrobiologists could not help but wonder. If Pluto possessed an internal ocean beneath its icy shell, as seismic models and impact simulations suggested, then within that ocean might lie the stability required for microbial life. Protected from cosmic radiation, nourished by chemical gradients, such a hidden sea could serve as a cradle for alien biology. On Earth, life thrives in the most extreme environments, deep beneath the oceans, in ice-covered lakes, in volcanic vents without sunlight. Could Pluto's hidden waters host something similar? The thought was staggering. For decades, the search for extraterrestrial life had focused on Mars, on Europa, Yet here, in the darkness beyond Neptune, Pluto emerged as an unlikely candidate, whispering of life where none had been expected. The encounter transformed Pluto from myth to reality. No longer a blurred dot at the edge of maps, it became a world of mountains, plains, skies, and perhaps oceans. To the scientists who watched those first images arrive, it was as though the universe itself had leaned closer, revealing that mystery still thrived in the places humanity had overlooked. The images from New Horizons were not just scientific data. They were poetry in pixels, a reminder that exploration was not over, that even in the 21st century, there were still new worlds to be seen for the first time. The heart of Pluto became an emblem of resilience, not just of the planet itself, but of human curiosity. Pluto, demoted and dismissed, had found a way to astonish once more, and yet the mystery deepened. For every answer, new questions bloomed. How could a world so small retain enough heat to drive geology? What source of energy pulsed within its core? How stable was its atmosphere, and how far did its chemistry go toward the threshold of biology? The flyby of New Horizons lasted only a few hours. After traveling for 9 years, the spacecraft's moment of revelation was fleeting. A brief encounter before it sped onward into the Kuiper Belt. It could not stay to orbit, nor to drill into the ice, nor to peer beneath the surface. It could only capture a glimpse. But in that glimpse, the universe changed. Pluto, the exile of the solar system, had revealed its heart. Not the barren silence of a forgotten rock, but the beating mystery of a world alive with possibilities. In that moment, the search for life expanded, no longer confined to warm planets or moons bathed in sunlight. It now stretched into the coldest shadows, into places where chemistry, energy, and time might converge in stranger ways. The story of Pluto was no longer one of exile, it was one of revelation, a reminder that life, in whatever form it may take, does not always bloom in light. Sometimes it hides in darkness, waiting for us to finally see. The first images from New Horizons were celebrated across the world. Mountains of ice, glaciers in motion, and a nitrogen plain shaped like a heart. Yet, beneath the awe, another emotion began to spread quietly through the halls of science: shock. For Pluto, a world so small and distant, had revealed itself to be alive in ways no one had anticipated. By every calculation, Pluto should have been silent. Worlds of its size are not expected to carry warmth within them for billions of years. Their heat, born from the chaos of planetary formation, leaks away into space, dissipating until they freeze into eternal stillness. Yet Pluto's surface was fresh, its glaciers were moving, its mountains were sharp, its plains bore no scars of ancient craters. Something was keeping this world warm, something hidden. The mystery forced scientists to look inward, into Pluto's very core. The question of planetary heat, arises in several ways. Some comes from the birth of the world itself, as gravity compresses raw material into a sphere. Some comes from radioactive elements, uranium, thorium, potassium, breaking down within the crust, releasing energy over time. Larger planets, such as Earth, retain heat far longer because of their size and mass. But Pluto, only 2/3 the size of Earth's moon, should have cooled to its heart billions of years ago. Yet New Horizons revealed a surface reshaped in recent times. Models of Pluto's geology suggested that its core was not frozen solid, but still stirred with warmth. The conclusion was as surprising as it was profound. Deep inside Pluto, heat remained, enough to reshape landscapes and drive geological activity. The ocean beneath Pluto retained heat. Then a second, more startling possibility emerged: liquid water beneath kilometers of rock-hard ice. Scientists proposed the existence of a vast subsurface ocean. At such great depths, pressure and heat could keep water liquid despite the frigid temperatures above. This idea was not born from imagination alone, but from evidence etched across Pluto's face. Sputnik Planitia lies in a basin aligned almost directly opposite Pluto's largest moon. The alignment hinted at a phenomenon known as true polar wander, where a planet shifts its orientation so that areas of greater mass move toward the equator. But nitrogen ice is less dense than the surrounding rock. For Sputnik Planitia to tug Pluto's orientation in this way, something denser must lie beneath it, a hidden ocean of liquid water, heavier than the frozen crust above, could provide the explanation. Cracks and fractures stretching across Pluto's surface further strengthened the case. These features suggested expansion, as if the planet had swelled from within. On Earth, such patterns often mark the presence of liquid reservoirs, freezing and expanding. Could Pluto's scars be the frozen echoes of an ancient, still-living ocean? An impossible survivor, the possibility of water on Pluto unsettled planetary science. Until then, subsurface oceans were imagined on larger, icy worlds, Europa, Enceladus, Titan worlds, warmed by the tidal pull of massive parent planets. But Pluto, drifting alone in the Kuiper belt, felt no such gravitational embrace. How then could its ocean survive? Several theories arose. Some suggested that Pluto's ocean was insulated by a thick layer of ice mixed with ammonia, which lowers water's freezing point and prevents it from solidifying. Others proposed that radioactive elements within Pluto's rocky core continued to release enough energy to keep the ocean from freezing completely. Still, others wondered whether Sputnik Planitia itself acted as a thermal engine, trapping heat in its depths. The sheer survival of such an ocean would mean that Pluto had clung to its warmth for billions of years, long after science had expected it to fall silent. It was a revelation that reshaped our understanding not only of Pluto, but of countless icy bodies across the solar system. The whispers of habitability with liquid water came a whisper that reverberated through astrobiology. Habitability, life, as known on Earth, requires water. In the deepest trenches of the oceans, where sunlight never reaches, microbes thrive near hydrothermal vents, drawing energy from chemical reactions rather than light. In Antarctica, buried lakes beneath kilometers of ice sustain ecosystems hidden away for millennia. Even in radioactive caves, shielded from sunlight and warmth, organisms endure. If life can persist in such extremes on Earth, could it not also endure on Pluto? The thought was staggering. Far beyond the warmth of the sun, in a world of nitrogen skies and methane frosts, the possibility of life emerged. Not life as familiar to humanity, but microbial forms feeding on chemical gradients in the dark, swimming in waters warmed by the slow fire of radioactive decay. A cosmic recalibration. Discovery of Pluto's potential ocean forced scientists to recalibrate their search for life. The habitable zone, once narrowly defined as the Goldilocks region around stars where liquid water could exist on the surface, suddenly seemed too restrictive. Life might not need a star at all. It might thrive in the frozen shadows, hidden beneath ice. Powered by chemistry rather than sunlight, Pluto became a symbol of this new vision. If even a tiny, distant world could harbor conditions for habitability, then the galaxy might be filled with such places, oceans beneath ice, scattered like jewels across the cosmos, waiting for life to emerge, the shock to imagination for scientists. Pluto's revelations were not just about geology or chemistry, but about possibility. Here was a world that had defied every assumption. It was supposed to be inert, silent, and forgotten. Instead, it pulsed with hidden warmth. It carried whispers of oceans. It held the raw materials of organic chemistry. It was as if Pluto itself had risen from the margins, demanding to be seen not as a relic, but as a participant in the story of life. And so the scientific shock deepened into something more profound, a philosophical awakening. If Pluto could harbor oceans in its darkness, then perhaps life was not rare, not fragile, but resilient beyond measure. Perhaps the universe was filled with forms of survival so alien, so unexpected, that they lay hidden in places humanity had never thought to look. Pluto had revealed a truth that unsettled and inspired in equal measure. The frontier of life was not only in the warmth of stars, but in the silence of frozen exile. What other secrets, then, were waiting in the shadows? The revelation of Pluto's restless geology and possible hidden oceans sent ripples through science. For if warmth and water existed beneath its frozen crust, then another question, more profound and unsettling, began to take shape. Could this distant world harbor life? The answer, if it exists, lies not only beneath the surface, but written across Pluto's face in the language of chemistry. A pilot of Esau's Pluto's surface is not the barren stone of airless worlds, nor the scorched deserts of inner planets. It is a shifting canvas of exotic ices, methane, nitrogen, carbon monoxide, frozen into plains and ridges, flowing and evaporating in a delicate dance with the thin atmosphere above. Methane, abundant in Pluto's crust, is far more than a simple hydrocarbon. On Earth, methane is both a geological byproduct and a biological signature, exhaled by microbes in ancient swamps and modern wetlands. Its presence alone on Pluto does not prove life, but in the cold vacuum of the Kuiper Belt, its persistence raises questions. For methane is unstable under sunlight and cosmic rays. Left exposed, it should break down over millions of years, erased by the harshness of space. Yet Pluto's surface remains coated with it, suggesting replenishment from within, perhaps from cryovolcanism, perhaps from deeper chemical cycles. Nitrogen dominates Pluto's plains and atmosphere, shaping its weather and carving its glaciers. On Earth, nitrogen is the breath of life, inert in the sky, yet vital in the proteins of every organism. On Pluto, nitrogen flows like water, creeping across Sputnik Planitia in glaciers that move as though alive, feeding a thin sky that collapses and reforms with the seasons. In nitrogen, Pluto carries both a lifeless frost and a reminder of life's universal ingredient, carbon monoxide. Rare yet present, offers another layer, toxic to humans, yet chemically rich. It hints at reactions that, under the right conditions, could yield complexity. Together, these compounds sketch a world where chemistry has not frozen still, but continues to churn. The red stains of chemistry, perhaps the most haunting signs on Pluto's surface, are not the gleaming whites of nitrogen ice or the dark voids of frozen plains, but the red stains painted across its face. These are tholins, complex organic molecules forged not by biology, but by radiation. When ultraviolet light from the sun or charged particles from space strike methane and nitrogen. They tear the molecules apart. Out of this destruction comes creation. Carbon and nitrogen recombine into longer, more intricate chains. Over time, these chains grow into tar-like residues that fall back to the surface, blanketing Pluto in shades of copper, crimson, and deep brown. Tholins are not alive. They are not cells or organisms, but they are the raw ingredients of biology, the precursors to amino acids, nucleotides, and the chemistry that forms life's scaffolding. On Titan, on Triton, and on comets, tholins whisper of complexity rising from radiation and cold. On Pluto, they tell a similar story, that even in darkness, chemistry marches forward toward life's possibility. Scientists studying tholins have recreated their formation in laboratories, simulating Pluto's conditions. The results reveal molecules resembling those that may have rained upon the early Earth, seeding the oceans with the potential for biology. In this way, Pluto becomes a mirror of ancient Earth, a reminder that life's roots may emerge not from warmth and sunlight, but from the stubborn creativity of molecules in hostile environments. The architecture of organic chemistry. Why does organic chemistry matter in the search for alien life? Because life, as known to humanity, is chemistry organized into self-sustaining patterns. Carbon, versatile and binding, forms the backbone. Hydrogen, oxygen, and nitrogen weave into chains, rings, and spirals. From these humble arrangements emerge proteins, enzymes, and the endless choreography of cells. The presence of methane, nitrogen, and tholins on Pluto does not prove biology, but it proves that the stage is set. The essential actors are present, awaiting the possibility of assembly. And if beneath the crust lies liquid water, then these molecules may dissolve, interact, and evolve in ways unseen. This does not mean life must be familiar. It may not breathe oxygen, nor metabolize in ways recognizable to Earth's biochemistry. Yet the principle is universal. Where organic complexity meets liquid stability, the potential for life stirs. Pluto holds both in frozen silence. Beneath the ice, if life exists on Pluto, it is unlikely to bask on the surface, where temperatures hover near -230 degrees Celsius, and radiation scours the landscape. Instead, it would hide beneath, in the dark sanctuary of a subsurface ocean, shielded by kilometers of ice. Here, water could remain liquid, warmed by radioactive decay and antifreeze compounds like ammonia. Here, chemistry could proceed undisturbed for billions of years. Microbial life, if it had ever sparked, might endure in this hidden sea, feeding on gradients of energy where rock meets water. On Earth, such environments teem with extremophiles, organisms thriving in boiling vents, in frozen Antarctic lakes, in the pores of basaltic rock deep underground. They require no sunlight, only the steady hand of chemistry. If such resilience exists here, could it not echo there, beneath Pluto's crust? Speculation stretches further still. If Pluto's ocean has endured since its formation, life may have had time not just to arise, but to adapt, to sculpt entire ecosystems invisible to human eyes. Microbes drifting in briny waters, feeding on hydrogen and methane. Biofilms clinging to mineral vents, perhaps even forms unimagined, with metabolisms alien to earthly biochemistry. The fragility of evidence yet, for all this speculation, proof remains elusive. New horizons captured only a fleeting glimpse, unable to pierce the ice or taste the chemistry of Pluto's hidden ocean. The evidence rests in inference, in fractures, in colors, in gases that should not persist. The puzzle is incomplete, the silence profound, and still science listens. Telescopes measure Pluto's atmosphere from afar. The James Webb Space Telescope peers into its spectral fingerprints, searching for subtle clues. Future missions are dreamed of orbiters, landers, even probes to melt through the ice. Each carries the same haunting goal: to answer whether the silence of Pluto hides life's whisper. The philosophical horizon, the search for signs of life on Pluto, is not only about a single world, but about the definition of life itself. If such a distant, frozen planet can harbor the chemistry of habitability, then the universe may be more alive than imagined. It challenges the boundaries of the habitable zone, once thought to be a narrow band around stars. It suggests that oceans beneath ice may be far more common than warm Earth-like planets. It raises the possibility that life is not fragile, but universal, not confined to sunlight, but capable of surviving in darkness, heat, cold, and chemistry. Pluto becomes more than an icy dwarf planet. It becomes a symbol of possibility, a testament to life's stubbornness, and a mirror of humanity's longing. Closing reflection, the red scars of tholins, the whispers of hidden oceans. Together they tell a story, not of certainty, but of potential. Pluto has not revealed alien life, but it has revealed that life may not be confined to Earth, nor to planets bathed in warmth. It may thrive in exile, beneath the ice of forgotten worlds, as scientists search for signs of life on Pluto. They are searching also for signs of themselves, for proof that existence is not a singular miracle, but a cosmic pattern. The question remains unanswered, but the silence is not empty. It is full of promise, and in that silence, Pluto waits, holding its secrets in the shadows of its frozen heart above Pluto's surface, where sunlight is little more than a distant star's echo. Something unexpected stirs, not emptiness, not silence, but an atmosphere, fragile, fleeting, yet alive with motion. It is thin, tenuous, a wisp of gas stretched across the cold expanse. Yet within its layers lies a mystery that deepens Pluto's enigma and challenges every notion of what a frozen world should be. The breath of a distant world, Pluto's atmosphere is built from nitrogen, the same gas that dominates Earth's sky. But here it is faint, only 100,000th the pressure of sea level on Earth. It hugs the planet delicately, rising into layers of haze that extend more than 200 kilometers above the surface. Seen by New Horizons, these hazes glow blue in scattered light, luminous against the black of space. Their formation is both simple and extraordinary. Sunlight and cosmic rays strike Pluto's upper atmosphere, breaking apart methane molecules. The fragments recombine into heavier hydrocarbons, drifting downward as they polymerize into complex aerosols. These particles scatter light, creating the blue veils, before falling gently to the surface, where they settle into tholin-rich deposits that paint Pluto's plains with red. This cycle of methane broken, rebuilt, and returned is more than chemistry. It is a sign of dynamism, a system in motion, delicate yet enduring, pulsing with the same rhythms that once shaped the skies of a younger Earth. The rhythm of seasons, but Pluto's atmosphere is not constant. It breathes with the rhythm of seasons that stretch across centuries, with an orbit lasting 248 years. Pluto journeys on an elliptical path that carries it from 30 astronomical units from the Sun to nearly 50 at its closest approach. Sunlight is enough to warm the nitrogen frost at its surface, causing it to sublimate into gas and swell the atmosphere. At its farthest, the air collapses, freezing once again onto the ground. This cycle of appearance and disappearance makes Pluto unique among planets and moons. It is a world whose skies are written not in permanence but in transformation, an atmosphere that vanishes and returns, a breath that pauses for decades before exhaling again. For scientists, this pattern is both puzzling and profound. It suggests that Pluto's climate is not static but dynamic, a complex interplay of frost, sublimation, and chemistry. A frozen world, yes, but one with a pulse, a mirror of early Earth. In this thin, changing air, researchers see echoes of something older, something closer to home. Billions of years ago, Earth's atmosphere was not the oxygen-rich sky of today. It was thin, rich in nitrogen and carbon compounds, stirred by ultraviolet light into complex organic hazes. The earliest Earth, in its infancy, may have worn skies not unlike Pluto's, blue veils of haze, red deposits of tholins, a chemistry poised on the edge of biology. The comparison is more than poetic. If Pluto's atmosphere can generate complex organics through photochemistry, then so too could Earth's skies have once seeded its oceans with life's first ingredients. Pluto, frozen and distant, becomes a time capsule of primordial Earth, a chemical echo of the cradle from which life emerged. It is a sobering thought that at the edge of the solar system, in a world once dismissed as barren, lie clues to humanity's own beginnings. The darkness beyond light, but this revelation carries with it a deeper tension. For if Pluto's atmosphere mirrors the early Earth's chemistry, could it also mirror the potential for life? And if so, what kind of life could exist in such a place? On Earth, life feeds on sunlight, transforming photons into sugars and oxygen. But in the darkness of Pluto, light is too faint, its warmth too weak. Here, life would require another source of energy, one not of the sky, but of the earth beneath. Chemistry becomes the sustenance. Methane, nitrogen, carbon monoxide, all can fuel reactions, releasing energy in subtle sparks. Deep beneath the ice, where water may remain liquid, these gradients could provide nourishment for microbes, just as bacteria thrive on Earth in caves, in hydrothermal vents, and in rocks deep underground. So too might organisms endure on Pluto, feeding not on light, but on chemistry itself. It is a vision of existence in exile, life hidden in oceans unseen. Breathing in the dark, its cycles driven not by seasons of sunlight, but by eternal chemical storms, the tension of possibility for science. This possibility is both exhilarating and unsettling. If Pluto can host even the conditions for biology, then the universe becomes far more fertile than imagined. Life may not be the rare bloom of warm planets close to their stars, but the hidden resilience of icy worlds orbiting in the shadows. The habitable zone may not be a narrow band of light, but a vast territory of darkness where chemistry and time conspire to create survival. Pluto, with its thin skies and frozen seas, embodies this tension. It is a world that should be dead, yet reveals motion, a planet that should be silent, yet whispers of complexity, an exile that reflects the dawn of Earth, escalation of the unknown, and so the mystery deepens. Pluto is no longer merely a world of ice, but a paradox, too small to hold heat, yet alive with geology, too distant to breathe, yet veiled in hazes, too frozen to stir, yet painted with organics. Every revelation raises another question. Every answer expands the unknown. What is the source of its enduring heat? How stable is its hidden ocean? How far has its chemistry traveled toward biology? And most haunting of all, if life exists in its darkness, what would it mean for humanity's place in the cosmos? The escalation is not only scientific, but philosophical. For Pluto forces humanity to confront a possibility long whispered, but seldom embraced, that life is not fragile, not rare, but universal, adaptable, and hidden in places unseen. Closing reflection. Pluto's atmosphere, fragile as it is, has altered the course of thought. It is not merely a veil of nitrogen. It is a mirror of Earth's past, a stage for chemistry, and a whisper of possibility. In its blue hazes and red plains, Pluto speaks of beginnings, of the resilience of molecules, of the potential for life without light. The escalation of Pluto's mystery lies not only in what it is, but in what it represents, that the story of life may not be confined to Earth, nor to warmth, nor to light. It may be a story written in darkness, unfolding beneath ice, nourished by chemistry, and awaiting discovery in the silence of worlds long overlooked. And in that silence, Pluto waits, its atmosphere a fragile breath, its surface a canvas of organics, its depths perhaps alive, not with certainty, but with possibility, the most haunting mystery of all. In the silence of the Kuiper Belt, Pluto drifts as an enigma, a frozen world at the edge of sunlight. Its icy heart, its hidden ocean, its crimson chemistry, all these hints whisper of possibility. But if life exists here, it would not be life as humanity knows it. It would be something stranger, something born of exile and adapted to extremes. This is where astrobiology enters, the science of imagining life beyond Earth, not only in familiar forms, but in possibilities unbound. For the question is no longer whether Pluto is habitable in Earth-like terms, but whether life itself could redefine its meaning in the shadows of this distant world. Life as we don't know it. On Earth, life is bound to carbon chemistry, liquid water, and an energy source, sunlight, or the chemistry of rocks. Yet even within these boundaries, life has proven astonishingly flexible. Microbes thrive at boiling vents, beneath Antarctic ice, within rocks deep underground, and even in radioactive waste. But arise from the same universal laws of chemistry and physics. Pluto, with its ammonia-rich Isis, methane plains, and hidden ocean, may be one such laboratory of invention. Here, life might not resemble the familiar. It could breathe chemicals alien to Earth's lungs, metabolize energy sources no terrestrial creature has ever touched, and build its structures from compounds frozen solid in any other environment. Lessons from extreme Felesto imagine. Plutonian life. Scientists turn first to extremophiles organisms that thrive in the most hostile places on Earth. In Antarctica, beneath kilometers of ice, lakes remain liquid, sealed away from sunlight for millions of years. Within these lakes, microbes survive on chemical reactions between rock and water. They do not need warmth, only chemistry. In the deep oceans, hydrothermal vents release jets of minerals and heat. Around them, entire ecosystems flourish, built on bacteria that transform hydrogen sulfide into energy. In caves contaminated with radiation, fungi adapt, feeding on the very energy that would kill other organisms. These examples reveal a truth. Life is stubborn. It adapts, survives, and reinvents itself. If such resilience exists on Earth, it becomes a mirror through which scientists glimpse what might unfold on Pluto. The subsurface ocean hypothesis, the most compelling model, begins beneath Pluto's icy crust. If a subsurface ocean exists, then its dark waters may host microbial ecosystems. Here, life could be fueled by chemosynthesis, the transformation of chemical gradients into energy. On Earth, microbes feed on the reactions between water and rock, producing hydrogen, methane, and other compounds. On Pluto, similar processes might occur where liquid water meets a rocky mantle. Such ecosystems would be small, slow, and hidden, but they would endure. Microbes could form mats on mineral surfaces, consume dissolved gases, and recycle nutrients over geological timescales. To them, the surface world would not matter. In the ocean's darkness, time would stretch, and survival would be its own quiet triumph. Cryovolcanic. Vents as refuges, but, perhaps, life does not remain sealed beneath the ice. The vast cryovolcanoes seen by New Horizons, Wright, Mons, and Picard, Mons, may once have erupted with slurries of water and ammonia. These outpourings could have carried the chemistry of the ocean to the surface, providing transient habitats for microbes adapted to darkness. Such eruptions might have been catastrophic or liberating. Some could perish, frozen in the exposure. Others might survive in pockets of warmth, clinging to minerals in the icy flows, waiting until conditions allowed them to sink back into refuge on Earth. Microbes have been found in volcanic ice caves, feeding on mineral-rich gases, surviving despite thin air and freezing cold. If such tenacity is possible here, could it not echo on Pluto's slopes, where cryovolcanism bridges the ocean and the sky? Exotic biochemistry. Some theories stretch further into the realm of life as truly alien. Water may not be the only solvent for biology. On Pluto, where ammonia is abundant, life could exploit ammonia-water mixtures, which remain liquid at colder temperatures. Ammonia could play the role of water, dissolving molecules and enabling reactions. Methane, too, may serve as a basis. On Titan, Saturn's largest moon, scientists speculate about methane-based life, feeding on hydrocarbons and exhaling ethane. If Pluto shares this chemistry, then exotic organisms might weave methane into their metabolism, creating structures unlike anything on Earth. Such possibilities remain speculative, but they expand the horizon of thought. If Pluto's life exists, it may not be carbon-water life at all, but something stranger. Life adapted not to light and warmth, but to shadow and frost. Sagan's legacy long before New Horizons. Carl Sagan dreamed of life in unlikely places. He spoke of Titan's methane seas, Europa's hidden ocean, and the potential of icy moons. To him, the universe was not barren, but rich with opportunities for biology. Pluto was not often named among his candidates, yet his philosophy resonates here. For if Titan's cold chemistry can inspire speculation, why not Pluto's? If Europa's ocean invites dreams of alien microbes, why not Pluto's hidden sea? Sagan reminded humanity that life should not be underestimated nor confined to Earth's narrow perspective. Pluto, with its chemistry and its silence, embodies that reminder. The weight of possibility, theory, microbial oceans, cryovolcanic refuges, exotic chemistries, remains unproven. No probe has tasted Pluto's air, no drill has pierced its ice, no eye has looked into its ocean. The evidence is indirect, inferred from fractures, colors, and models, and yet the weight of possibility grows. Pluto has the ingredients: water, chemistry, energy, time. It has the structures: oceans, vents. What it lacks is confirmation. But perhaps confirmation is not the point. For in the act of imagining life on Pluto, humanity reshapes its own vision of the cosmos. No longer is life tied to warmth and sunlight. No longer is habitability a narrow band around stars. Life, if it exists here, could exist anywhere. Closing reflection theories of alien life on Pluto are more than speculation. They are exercises in humility, reminders that human imagination is only beginning to grasp the resilience of existence. Whether in the dark waters beneath the ice, in cryovolcanic plumes, or in chemistries unimagined, life may find ways to endure. If Pluto is alive, it would not be in forms familiar to human eyes, but in whispers, microbial, chemical, alien. Yet even whispers would be profound, for they would tell humanity that life is not Earth's alone, not a fragile accident, but a cosmic inevitability. Pluto, in its exile, may be carrying that secret still at the edge of the solar system. Pluto drifts in silence, its secrets sealed beneath kilometers of ice. To glimpse them, humanity must build tools that reach beyond imagination, machines that carry eyes sharper than telescopes, ears tuned to the faintest signals, and endurance to survive the coldest frontiers. The search for alien life on Pluto is not only a story of geology and chemistry, but also of the instruments forged to reveal them. New Horizons, The Messenger. The first chapter of Pluto's unveiling was written by New Horizons. Launched in 2006, it was a machine of extraordinary simplicity, a grand piano-sized spacecraft, armed with a suite of cameras, spectrometers, and detectors. For nearly a decade, it sailed outward, its power supplied by a plutonium heart, its silence broken only by the faint whispers of radio waves traveling back to Earth. When it swept past Pluto in July 2015, New Horizons captured data that would astonish the world. The archive it returned, terabytes of images, spectra, and measurements, painted Pluto not as a frozen relic, but as a restless world. Sputnik Planish's youthful plains, the blue haze of its skies, the possible cryovolcanoes that hinted at hidden oceans. All of these revelations came from the eyes of New Horizons, and yet, for all it showed, the spacecraft left deeper mysteries. It did not orbit. It could not linger. It could not probe the depths of Pluto's crust, nor measure the composition of its hidden ocean, nor follow its atmosphere across decades of seasonal change. It offered only a glimpse, leaving scientists with more questions than answers. What drives Pluto's internal heat? How thick is its ocean? How stable is its atmosphere? And most haunting of all, does life lurk beneath its crust? The archive of New Horizons remains a foundation, but it is only the beginning. James Webb, the distant witness in 2021, another eye opened, far from Earth. The James Webb Space Telescope, designed to peer into the earliest galaxies, it has also turned its gaze closer to home. From a vantage point beyond the moon, Webb's infrared instruments have studied Pluto's spectral fingerprints through its eyes. Pluto's chemistry sharpens into focus. Methane frost, nitrogen plains, and traces of carbon monoxide are revealed with exquisite detail. The variations in color across its face hint at the distribution of tholins, the organic residues that coat its surface in crimson hues. But Webb's contribution is not limited to the surface. Its sensitivity allows it to detect subtle shifts in Pluto's thin atmosphere, the collapse and regrowth of nitrogen haze, the seasonal breathing of a distant world. Over decades, Webb may help chart whether Pluto's skies are stable or in decline, answering whether its atmosphere is a permanent feature or a fleeting phase. Yet even Webb has limits. From Earth's orbit, it can measure only what light reveals. It cannot drill, it cannot dive, it cannot taste. For the next step, humanity must send new messengers. Proposals for the future scientists have long dreamed of a Pluto orbiter. Unlike New Horizons, such a mission would not pass swiftly by, but circle Pluto for years, mapping its surface in detail, monitoring its atmosphere through seasons, and measuring its gravity with enough precision to infer the structure of its hidden ocean. But to orbit Pluto is no small task. At nearly 5 billion kilometers away, it takes immense energy to slow a spacecraft enough to be captured. Nuclear propulsion, advanced ion drives, or gravity assists on unprecedented scales would be required. The cost is vast, the challenge immense, and yet the reward would be profound. Beyond orbiters, some envision a lander to touch down on Pluto's icy plains, to scoop tholins from its surface, to analyze ESIS with onboard laboratories. Such an endeavor could reveal whether organic chemistry has advanced toward biology. It would be humanity's first direct contact with the soil of a Kuiper Belt world. Still bolder are proposals to reach beneath the ice. Concepts exist for nuclear-heated probes, cryobots, capable of melting through kilometers of crust, carrying instruments to plunge into the ocean below. Such technology is being studied for Europa, Jupiter's icy moon, and Enceladus, Saturn's oceanic satellite. For Pluto, the challenges multiply. The distances are greater, the ice thicker, the communication slower. Yet the dream persists. To send a machine into Pluto's ocean would be to listen for whispers of alien life in the deepest silence known. Learning from other missions, though, no mission is yet bound for Pluto's ocean. Other spacecraft blaze the trail. The Europa Clipper, set to launch in the 2020s, will orbit Jupiter and sweep repeatedly past Europa, probing its ice and searching for signs of habitability. Instruments aboard will measure the thickness of its crust, analyze plumes of water, and map the composition of its surface. The Dragonfly mission to Titan, Saturn's largest moon, will send a rotorcraft to explore dunes of methane ice and lakes of liquid hydrocarbons. It will test for complex organics, searching for chemistry that may mirror or diverge from life. These missions are not to Pluto, but they show a path. They prove that science can design machines to probe oceans beneath ice, to analyze alien chemistry, to fly in skies unearthly. What is learned on Europa and Titan will shape the tools that someday may reach Pluto. Why Pluto is harder, yet Pluto remains a special challenge. Its distance means signals take nearly 5 hours to reach Earth, and spacecraft take decades to arrive. Its low gravity makes orbit capture difficult, requiring immense braking maneuvers. Its ice may be far thicker than Europa's, making penetration nearly impossible with current technology. But harder does not mean impossible. Nuclear propulsion, autonomous navigation, and advanced power sources are being developed. If humanity can cross the gulf once with new horizons, it can do so again, this time with tools to stay, to listen, to dig. A philosophy of instruments. Every tool humanity builds is more than metal and circuits. It is an extension of curiosity, a lens through which the universe reveals itself. New horizons showed the face of Pluto. Webb reveals its chemistry. Europa Clipper and Dragonfly test the methods that may one day be used here. Each mission is not isolated, but part of a continuum, the slow unfolding of exploration across decades, across generations. For Pluto, the tools of discovery are not yet finished. They remain in sketches, in proposals, in dreams. But the questions they are built to answer are already known. Does Pluto's ocean exist? How thick is its ice? How complex are its organics? Could it host life? Closing reflection. The search for alien life on Pluto is inseparable from the tools humanity builds to find it. Without spacecraft, it is invisible. Without telescopes, it is silent. But with instruments forged in curiosity, the unseen becomes visible. The silence becomes full of meaning. The tools of discovery are not only scientific, they are philosophical. They remind humanity that knowledge is never given, but earned through patience, through invention, through the courage to send fragile machines into the dark. Pluto waits, its ocean sealed, its atmosphere breathing, its surface painted with crimson chemistry. The tools of today have revealed only the surface of its mystery. The tools of tomorrow may pierce the ice itself, and when they do, humanity will listen, not for certainty, but for possibility. The possibility that in the frozen silence of Pluto, life has written a story of survival, unlike any ever known in the silence of the Kuiper Belt. A question lingers, like starlight stretched thin. What would it mean if life existed here, in the frozen dark of Pluto? Not complex beings, not civilizations, but microbes, fragile, hidden, enduring. Their discovery would not merely alter planetary science. It would reshape humanity's understanding of the universe, of life, of itself. Life in exile. Pluto is alive. It would prove that life does not require the warmth of a sunlit sea, nor the shelter of a temperate sky. It would show that biology is not a rare flower of Earth, but a weed of the cosmos, growing wherever chemistry and energy find a foothold for generations. Humanity's gaze has been anthropocentric. The habitable zone, the so-called Goldilocks region around stars, has long defined the search for life. But Pluto would break that rule. Its ocean lies buried beneath kilometers of ice, warmed not by sunlight but by the slow decay of radioactive elements, by the antifreeze of ammonia, by the quiet persistence of geology. Life here would mean that habitability is not narrow but vast. It would extend not only around stars but across galaxies, hidden in icy shells, in dark oceans, in places where warmth is measured not in light but in persistence, a universe alive in shadows. If Pluto, smallest of worlds, can harbor life, then the implications spread outward like ripples in water. Europa, Enceladus, Titan, Triton, all icy moons with oceans beneath their shells, would be even more promising. And beyond the solar system, billions of exoplanets orbiting faint red dwarfs or drifting in interstellar space might conceal biology within. The universe may not be silent. It may be alive in countless hidden places where no sunlight reaches, where chemistry builds not for beauty but for survival. In this vision, Earth is not the center of life, but one example among many. The cosmos itself becomes a cradle, filled not with emptiness, but with seeds. Einstein and Hawking, time, space, and fragility. Einstein once wrote that the eternal mystery of the world is its comprehensibility. If life exists on Pluto, it speaks directly to that mystery. For the same laws of physics that bend light around stars may also allow cells to survive in exile. Relativity teaches that time stretches at the edges of gravity, that the fabric of the universe is pliable. In Pluto's remoteness, time itself feels different, centuries passing like seasons, orbits measured in lifetimes. Life here would echo that scale, patient, enduring, shaped not by rapid change, but by the slow hand of cosmic time. Stephen Hawking spoke of humanity's fragility, of the thinness of the biosphere that sustains life on Earth. If Pluto holds organisms beneath its ice, it would remind us of life's resilience beyond that fragility. It would show that existence is not a singular miracle sheltered under Earth's skies, but a universal tendency written into the laws of physics and chemistry themselves. The end of solitude for humanity. The meaning would be deeply emotional. To know that something lives on Pluto, even microbes, drifting unseen in a dark ocean, would dissolve the oldest fear, that humanity is alone. It would mean that life is not confined to Earth's narrow story, but woven into the universe itself. It would not matter that these organisms could not speak, could not build, could not dream. Their very existence would be a voice saying simply that life happens, that the cosmos is not indifferent emptiness, but fertile, creative, alive. Such a revelation would echo through philosophy, religion, and culture. It would challenge every worldview that placed humanity at the center. It would humble us, yet also console us. In the immensity of space, we would know that we share the story of existence with others, however small, however distant. Redefining alien life has often been imagined as strange, threatening, or grand. But on Pluto, it would be subtle, microbial, nearly invisible, and yet its meaning would surpass even the most extravagant science fiction. For alien does not mean hostile, nor intelligent, nor powerful. It means simply, not us. To find not us on Pluto would transform the word itself from fear to kinship. For in its resilience, we would see a reflection of our own life surviving in darkness, refusing extinction, crafting survival from scarcity. Alien, then, would no longer mean other, but inevitable. The cosmic implication: if life exists on Pluto, then life is likely everywhere. The probability shifts, the statistics transform. One example beyond Earth makes two, and to suggest a multitude, it would imply that life is not rare, not fragile, not a miracle against odds, but a natural outcome of chemistry and time. The universe would become not a stage set for humanity alone, but a living system, its corners filled with biology, adapted to every niche. This would not diminish Earth's importance, but expand it. For Earth would no longer be the only cradle of life, but part of a vast archipelago of living worlds. Humanity's story would not be singular, but shared. The human longing beneath the science lies a truth more personal. Humanity's longing to not be alone. Across cultures and centuries, myths of other beings, other lives, have filled stories and prayers. To discover life on Pluto would fulfill that longing, not with gods or monsters, but with the quiet endurance of microbes. It would tell us that existence is not isolated, that the silence of the cosmos is not empty, but waiting to be heard, that in the frozen heart of Pluto, and in the countless worlds beyond, life is writing its own verses in the universal poem. The haunting clospur, perhaps the greatest secret of life, is not found in the warmth of Earth's seas, nor in the light of its skies. Perhaps it lies instead in the shadows, in dark oceans beneath ice, in crimson tholins painted by radiation, in the frozen exile of distant worlds. If Pluto carries even the faintest spark of biology, then it proves a truth both humbling and profound. Life is not Earth's possession. It is the universe's inheritance. And so Pluto waits, in silence, in shadow, in exile, holding a secret that may one day redefine everything humanity knows. Not the roar of civilizations, not the chorus of stars, just a whisper, faint yet eternal, that life exists where none was expected. And in that whisper, humanity will hear the answer to its oldest question.